Let's study another data structure called queue. Stack and the queue are similar, but the only difference is that the stack, the order is last in first out order. So last data entered should be removed first, while queue is first in first out. We call FIFO in other words. So they are storages. They are to store data, but the only difference is that order of removal compared to the insertion order. That's the only difference. So we are going to study two implementations as we did in stack. So a finite queue based on the array, and then infinite queue based on dynamic memory allocation. So queue is a first in first out. So it's a same idea from the daily life that we have a waiting line. So this is the place. Then we have a waiting line like that. Then here is a service desk. Then first one or front one on the waiting line will be served first, removed first. This is the first that came in, and then here is the back of the waiting line. As a new person comes in, will be added after the back of the waiting line. So to implement this idea in an array, we can just imagine an array like that. Array index 0 and then size -1. So as you add data, let's call it as a push operation. Then you add data the very first slot. And then if you do push again, we are going to add here. Then as you do pop, we are going to take this first data out. And then as you do push, we add the data here. Now we do pop, we remove that. In real life, as the person on the front of the queue is served, all the others will step forward, move forward, so that always the front is here. But if we use a array implementation like that, the front is moving. So as this is popped out, the front of the queue is moving, and these are emptied and so on. But if you keep pushing towards the very last, and then if we keep pop, take it out, then here we cannot add anymore, even if we have plenty of spaces there. So linear array simply like this will not work well, since we are eventually reaching the end of the array. So the other idea is that to overcome this idea is that we do circular array. Circular array is something like this. So instead of considering array as a linear one, just consider array is round, and then first at index 0 and the last index last -1, they are adjacent. So that as you will do push and the pop, we can just go across the borderline here. So in doing so, we need to have two indexes stored. So let's have it as I front index. Where is the index for front of the line? And then I back. Those two needs to be maintained. So if we have first data pushed, if we do push 5, 5 is stored at index 0, and then front is 0. That's the index of the very first data, that is a 5. And as well, the very first data, the only data, the index for front is 0, index for back is 0. As we do push 6, then 6 should be stored there, which is at index 1. Then I back, the index for the back is incremented by 1. And then as we do push another data, 7 is stored, which is at index 2. So index of the back will be incremented. So if we keep adding that, eventually the data may be stored here in n minus 1. It's a baggage. Suppose this is just 10 elements, then last index should be 9. So at index 9, 100 is stored. So it's a full at this moment. And now, if I do pop, then 5 will be removed. Then index of the front will be 1. So this will be the front. Then this slot is emptied so that you can push now another data. Now if I do push with 200, then 200 could be stored in this location, and then back becomes 0. From 9, index 9, next index is 0. So that's emulation of a circular array. So if I do pop again, this is removed, and then front index it will be 2. If I do pop again, this is removed, then front index is 3, and the like. And then you can push more data, and then push goes through there. So the last index of the array and the first index of the array are wrapped around, connected or adjacent. So this is called the circular array. So we are going to implement this one in array-based finite queue.